This is John Black, Super Chemist, Part 2. Now I got my nitronium ions. Now I put my nitronium ions in the freezer till it got down to -8°C again. I'm just going to pour it slowly onto this cotton. See, I got an ice bath here underneath here I'm going to put in first, actually. Definitely making fumes. And you can see I put a lid on it. This lid, it's actually not a lid, but it works perfectly to keep the fumes in check. Keeping it at 0. And first couple hours, every half hour, I'd flip it. These tongs, right? Oh, God. You can see still liquid. This cloth is pretty much frozen, or feels frozen, but the liquid itself, oh jeez, the liquid itself, oh jeez. The liquid itself is, you know, it's still liquid. It's not frozen. I just wanted to go over some safety stuff. This is not an instructional video. It's just an educational video. This is making an explosive. If you don't do it correctly or you don't know what you're doing, you know what I mean, you could burn down your house, blow off your hand, you know what I mean, something like that effect. So I don't condone anyone repeating anything in the video. Now so far all we've done is we've nitrated the cotton, right? Put the nitronium ions onto the cotton and I'm getting ready to wash it. Now this is where it gets more dangerous because not only do you have to deal with the acid fumes, you have to deal with drying it. I want to go over a word called pyrocellulose. Pyrocellulose is just basically unwashed nitrocellulose, or it isn't properly washed. You know what I mean? It's not properly washed, or it's not even washed at all. Okay? And you see the word pyro, right? So you know what that means. Yeah, that means if it's unwashed or it's not washed properly, it will spontaneously combust. given enough time. You know what I mean? It could be a minute, could be a month. You don't know. That's the whole thing. You don't know. I did want to go over, this is the safest, this guy here, what's his name? Frederick Augustus Abel. He developed the first safe process to make gun cotton. Okay? And three of the things that he did different from everybody else was he went from a 1-to-1 ratio, which is what most people were doing, or they were doing even less than that. He took it up to a 2-to-1 ratio, meaning twice as many moles of sulfuric acid as nitric acid. Right? The way I did it in mine, I have 3, 3, and 1. Right? 3 moles, which would be a 1-to-1 ratio here. Right? 3 to 3 would be 1-to-1. He's saying it's safer to do double that, double the sulfuric acids. Okay. And the thing about that is, no matter what, you're going to have to add in extra. You noticed even on mine, I had to add in an extra mole and a third of a mole just to have enough liquid to cover up the cotton. Okay. So adding this much sulfuric acid is basically a filler, in my belief. You know what I mean? You can say it sequesters water. We're throwing in 70% concentrated nitric acid, and this is making water. I mean, there's so much water in there. I mean, you can only sequester so much water. It does make it be more liquidy so that the nitric acid can get spread around and make its nitronium ions and be more reactive in that way through accessibility of there being more liquid. You know what I mean? I think that's the whole, that way you get full nitration, because he's doubling it here. And like I said, that way you have a lot more liquid, a lot more room that, can be moved around, a lot more nitration. Me, I just added in some, I've said screw it, I added both extra in. You know what I mean? My extra filler was actual nitronium ions. But he's saying this is the safest way, right here, right there, safest way, or the safest ratio. Then the second thing he did was he extended the wash time to 48 hours, okay? And then he made everyone wash it 8 times. 8 times, not just once, not just twice, 8 times, each time being a 48-hour wash, okay? And even then, you're not guaranteed that this will not spontaneously combust, okay? And that's why we'll get into storage at the end, but that's why you don't just store this out in the air or store it in a jar or store it in something like that. You got to store it in a liquid. You know what I mean? We'll get into that later, though. Another thing I wanted to go over was you need to dry it below 40 degrees Celsius. So that's only 104 degrees Fahrenheit. I mean, that's, if you live in the desert, it's hotter than that. You know what I'm saying? If you live in Florida, it's hotter than that. I need to be careful about that aspect too. That so my basement, I have it, actually the entire house except the room I'm in, is all at about anywhere between 2 degrees Celsius and 5 to 8 degrees Celsius. So I don't really have a problem with this, drying it or whatever. But anyways, we're going to get into it right now. We're going to start washing it. We're going to start the wash process. But I did want to bring up that even after, you might think that it only can spontaneously combust while you're drying it. As long as you keep it below 40 C, you're okay. That's just not, I mean, that's true, but that's not the only time that it can spontaneously combust. Anytime after you dry it, you always, unless you store it in water or store it, we'll get into that. But if you just let it sit there, you throw it in your drawer, or just a drawer or cover it, or throw it in a bottle or whatever, jar. You always have that possibility that it will spontaneously combust. But it can ignite at any time after. That's why industrial places, even back in the mid 1800s, 1800s, or whatever, they stored it under some kind of liquid like alcohol, because otherwise you're just asking for it to blow up. Keep in mind, the safest way to make this is to actually have the sulfuric acid be twice as much as the nitric acid, a 2-to-1 ratio. I just wanted to bring this up because I'm not doing it that way, even though it is the safest way. So you should put in 6 moles of sulfuric acid compared to 3 moles of this and 1. Alright, the first thing I'm going to do is soak this in water. Since I have a cold water, since I have an ice bath here, I'm just going to use it. See, I got a lot left. Notice how it's completely covered in water. Alright, I got another 60 grams. It's a little bit over a third of a mole. A little bit more than a third of a mole of cotton. I'm going to put it into here. There's still stuff in there. I got a little over a mole of baking soda in there, 100 grams. That's cold water. Okay, now this. Alright, so I'm just going to let that sit in there for about a day, or at least until it stops bubbling. So it's been about 3.5, 4 hours. Bubbling stopped. Keep in mind, we put in 4 moles of sulfuric acid, and that's all just catalyst. And we only put a mole, or a little bit more than a mole of base in there. So it's probably still acidic. So we're going to do it again. We're going to put another 100 grams of baking soda in water. We're going to neutralize it more. Okay, there's the new water. It's the new baking soda. Yeah. Still acidic. It wouldn't be bubbling like that, right? So I'm going to put something heavy on there again so it sinks to the bottom. And we'll wait till it stops bubbling again.